Algebra 2, we're looking at lesson 11.12. We're looking at two-way frequency tables. We're also going to get into conditional probability. Both of these topics are actually topics that you're going to see on the SAT. So a company, we can read an example one, has male and female employees. The company has shirts and jackets with the logo to give away to employees. So you've got 220 employees. You don't have to add up every single item in the table, thankfully. A manager asked which piece of clothing the employee prefers, and the preferences based on gender are summarized. So we're going to go to the nearest hundredth, and what is the probability that you randomly select an employee, and that person is a female and prefers a shirt? So you have to be a female and you have to prefer a shirt. And guys, that means both conditions must be met at the same time. There are 52 females who prefer a shirt out of 220. And this is where right now you go ahead and type this out into the calculator, 52 divided by 220, and you'll get about 0.24 when you round to the nearest hundredth. Take a look at the next problem, though. It says, what's the probability that the employee is a female or prefers a shirt? Well, that means either condition or both is going to be okay. The females, you can see, 52 females prefer a shirt, 11 prefer a jacket. But when it says or prefers a shirt, that means you don't have to be a female. You could also be a male just preferring a shirt. What are we seeing? Well, you can see that the three little entries that I just highlighted there are what we're really looking at. You're going to see that we need 66 plus 52 plus 11. And that's going to be 129. So it's 129 people that we've highlighted in yellow. We're going to divide by 220. And when we do that, we're going to round to the nearest hundredth. You can see that would be about 0.59 because the 6 bumps the 8 up to the 9. All right, well, let's take a look at another problem here. This one is saying we have a deck of 8 cards numbered 1 to 8. Some are white. You can see the majority of them are white. One of them happens to be gray right here. That's the 3 card. They're saying what's the probability that a card drawn at random would be a 4? And we want to write our answer as a fraction here. Well, we've got 8 total. And this is the only way a 4 can show up. You've only got one 4 card there, so it's 1 out of 8. But for part B, we're going to get into what we're calling conditional. Conditional probability means you have more information. You're going to be told, given that the card is white, what's the probability of getting a 4 given that the card is white? We know that the card is white. It's like a friend tells you, look, I saw the card that was drawn. I didn't see the number, but I can tell you for sure it was a white card. That means it can't be the 3. And you can think, well, what does that really mean? Well, it means you don't have 8 possible cards anymore. You actually have 7. You lost one of your 8, so you've got 7. And they're saying, what's the probability that the 4 card shows up? Well, out of these 7 white cards, only one of them has a 4 on it. So that's 1 out of 7. So here's a larger table. And these problems, guys, are generally going to have one being conditional. You'll see a given statement there. And one that's just regular. So we've got 184 customers in this fitness studio at this gym. And some of them are new customers, some of them are not new, they're returning customers. And we've got people who've taken yoga classes, dance classes, boxing, or Pilates. And what's the probability that the customer took a dance class given that the customer was new? What that means is the not new customers are out of the way. We're not even looking at the returning customers, the not new. Given means you shorten your sample space. You look right here, you've got 34, well, we can do this, 34 plus 11 plus 33 plus 24. We're going to have to add these up. So just have to be patient and get this typed out. But you're going to see that altogether we have 102 new customers. 102 new customers. How many of them took a dance class? Well, 11. Now, of course, you should always check and see if you can reduce your fraction. The numbers are getting a little bit larger, so we should make sure. Although I think you can see quickly that 102 is not a multiple of 11. And that is your probability. So given that the customer was new, you no longer have 184 customers to consider. You've got just the new ones, and that's just out of 102. So let's just say that you want to find, for part B, the probability that the customer took a boxing class. Look, now you've got 184 customers, new and returning. You've got everybody. You're not told that you have a new or a not new customer. It could be anybody. And the boxing, well, wow, we've got to be careful here. It's 33 and 5. 33 and 5. Guys, you can add that up. That's going to be 38. Well, this thing we can reduce, and we'll get 38 over 184. We can get that going here. You can see it's going to be 19 over 92. Okay, so as we go to our last page, it's more about notation. It's more about the symbols that we have here. And let's see. Okay, going to this very last page of the packet, conditional notation. When you see this vertical bar here, that involves conditional probability. It means you're asked to find the probability of event A given that event B has occurred. So the first thing you can see, that's what we're trying to find. This is after the bar is what you know has happened. And when you know something has happened, it's going to limit your table. You won't have everybody in the table. You'll just have a little part of it. So let's take a look at this last example. A local high school has both male and female students. You've got 60 students total. 8 males play a sport, 16 do not play a sport. For girls, for females, 27 play a sport, 9 do not. So let female and males come into play here. Find the probability that a female is randomly selected. We want to have an exact decimal. Well, you can see right here, you've got 27 females who play a sport, 9 who do not. 27 plus 9, I think you can see pretty quickly, is 36. So it's 36 out of the 60 kids here. And, again, you're going to be writing this as a decimal. So we're just going to quickly type in 36 divided by 60, and we'll get 0.6. Well, how about no sport and a female? Well, both conditions have to be met at the same time, and the only one that is going to be met for both conditions would be right here. It's not enough to just say you don't play a sport. You also have to be a female, so that's going to be 9 out of 60. So we'll get 9 out of 60 here, and we'll get 0.15. Finally, you know that you have a female. So in other words, the males aren't part of this sample space. Given that you have a female, what's the probability that you select a female who doesn't play a sport? Well, we just saw from part A that there are 36 girls. Now, that's the 27 plus 9 that we just saw. Out of those 36 kids, how many of them don't play a sport? Well, that would be 9. So we're going to get 9 out of 36, which is going to be 0.25. And that is it for that lesson.